another circuit from Radio Constructor, British magazine, 1975, January. It is the so-called flip-flop. Two transistors are in a certain equilibrium state, but when you push one switch, one LED goes off and the other one on, and when you push the other switch, switch 2, that switches. So the LEDs, this one goes off and this one goes on, and in a reversed way. My idea was, well, let me modernize it and don't use a light emitting diode, but use a relay. And that resulted in this schematic. I will tell more about it. There are, say, a few things to tell about that very simple circuit. That's here. The problem is that when you switch, when you add voltage to that circuit, it could be that this transistor switches off or on, or that one switches off or on. So there is not a kind of, as far as I know, not completely sure, because in my circuit there is a kind of metastable circuit where both LEDs are off. Could be that due to all the changes that I made, used other transistors and used the Darlington, the effect is that we have a good metastable state, but in this circuit that's not the case. Well, let me demonstrate it. So here is the circuit on the breadboard. This is that Darlington flip-flop made with BD139, two BD139s, each one is a Darlington, and this second Darlington drive the 12-volt relay. That's here. Got a big bunch of them, by the way. These are industrial relays, very interesting and very high quality. But of course you can also use, say, a hobby relay, as long as the resistance of that relay is in the order of 130 ohm up to, say, 500 ohm maximum. So again the schematic. And here how you can make it with the shortest possible wiring. I tried to give a cure for that switch on effect, and I did it in two ways. The switch on effect, I mean that it is not certain whether the relay will be on or off when you switch the voltage to the circuit. And I did it in two ways, by using here this 10 ohm resistor, and very, very important, this 100 microfarad capacitor that parallels the relay. You can see it here. And also a diode parallel to the coil of the relay, more or less a standard thing. Anyway, what's the effect of this capacitor? The effect is that when you switch the voltage on in a, say, a random way, the circuit is stable, because the relay, due to that capacitor parallel to the coil, acts delayed, somewhat delayed. So it cannot act, the whole circuit cannot act on certain, say, sudden voltages sent to the circuit. Let me demonstrate that first. So here's the positive lead. It's now on 12 volt, and I do this. So I give it voltage, but the circuit doesn't act. And that's important. Let me show what happens when that capacitor is not there. I think that's interesting to show. I have to use the soldering iron for a while. So now the capacitor is disconnected. What happens when I add here the voltage? Well, perhaps due to the, well, this is, you heard it. It can happen that when you switch on the power supply, the relay switches on, and that means also that, say, the contacts here, when you connect it to a fierce lamp or a motor or so, that motor will start to run, and that's of course not the idea. So I connect, my camera starts to flicker, so I have to do it all very quick. Now the capacitor is connected again. So I give voltage now again to the circuit. I push this switch and it goes on here, and I push this switch here, it goes off. Switch 1 on, switch 2 off. So that was more or less all to tell. Very simple circuit, useful, but of course when you copy it out of an old book, there's always, you always have to search to find a good situation, and this is especially say important by when you make multivibrator circuit. This is in fact also a kind of multivibrator. It's a flip-flop, but say it belongs to the category of multivibrators. So anyway, I hope it is a little bit useful. I did my best to make it as stable as possible, and thanks for watching. Let's click for a while, always fun.